AMC problem 10. What is the following value of n given the logarithmic expression? So for any log problem, you always want to memorize these two fundamental formulas, which is the change of base and the product rule. You don't really necessarily need to memorize the division rule because that's just the same thing as log of a times 1 over b. Therefore, it comes back to this formula, so you don't really necessarily need to memorize multiple. You only need to memorize these two, which we're going to use to solve the problem today. So for any log problem, you typically want to solve it for the lowest base. So in this case, we have 2, and everything else is a multiple of 2, so we know that changing everything to base 2 would lead us to the right track, if not, get us close to the answer. So let's do that. We always want to go inside out, because that way we can evaluate everything as a whole. And to do that, got to go inside out, so let's do that. Log base 2 of log base 16 of n becomes log base 2 of n of log base 216, according to the formula, is equal to log base 4 of what? The inside out, so log base 2 of n over log base 2 of 4. Now, what is log base 2 of 16? 16 is just 2 to the 4th, so that becomes 4. But it's in the denominator, so that becomes log base 2 of 1 over 4 times log base 2 of n gives log base 4 of, log base 2 of 4 is equal to 2, but it's in the denominator, so that becomes 1/2 of log base 2 of n. Given this information, how do we solve it further? Well, inside out. So we have a product and we have a product. So let's evaluate that product into the summation of two logs. That becomes log base 2 of 2 to the negative half if we rewrite 1 over 4 plus log base 2 of log base 2 of n gives you log base 2 squared of 2 to the negative 1. That's a log. That's a terrible log, but plus log base 4 of log base 2 of n. If we evaluate this out, we get negative 2 plus log base 2 of n should give you negative half plus log base 4 of log base 2 of n. But wait, this is not in terms of base 2, but the inside is already on base 2, which is log base 2 of n. So let's rewrite log base 4 of log base 2 of n into log base 2, which is log base 2 of log base 2n over log base 2 of 4. Now log base 2 of 4 is just log base 2 of 2 squared, which gives you 2, but it's in the denominator, so that becomes 1/2. So log negative 2 plus log base 2 of log base 2n gives you negative half plus 1/2, because remember 2 is in the denominator, times log base 2 of log base 2 of n. Notice we have log base 2 of n, log base 2 of log base 2 of n on both sides. So if we assume log base 2 of log base 2 of n to be equal to x, we get negative 2 plus x is equal to negative half plus half x, right? And we just have to do a simplification and we get x. So that becomes, if we move half x over, becomes half x is equal to, if we move negative 2 over, that becomes negative half plus 2, which gives you 3 over 2. Now, this will give you x is equal to 3. If we plug it back into here, we know that log base 2 of log base 2 of n is equal to 3. But if we take the power of 2 on both sides, we eliminate this outer log, and we get log base 2 of n is equal to 2 to the 3rd, which is equal to 8. Now, that means that log base 2 of n has to equal 8. That means n is equal to 2 to the 8, right? And what is 2 to the 8? Because we're trying to find the summation of its digits. Well, a special power of 2 that you should memorize is 2 to the 10, which is equal to 1024 always. From there, you can multiply factors of 2 or other powers of 2 to derive your answer. So in this case, that can be written as 2 to the 10 over 2 squared, which is just 1024 over 4. And if we were to evaluate that, that would just equal 256, right? 256, that's correct. So what is 2 plus 5 plus 6? That's equal to 7 plus 6, that's equal to 13. So we should have a choice with answer 13. And if you scroll up, indeed, answer choice E is our correct answer.